Hi everybody, welcome back. We're going to push ahead with module 2.2. The focus of this module is going to be accessibility, clarity, and interactivity. So we're going to take some of the same types of visualizations that we were doing in module 2.1 and make them more accessible, clearer, and interactive. And we're going to start off with a discussion in this lesson about color schemes. And how those relate to accessibility, and specifically the issue of color blindness. So we want to be concerned with color blindness for two reasons. First, it's good to be kind to people with color blindness or other issues related to accessibility. But second, there's also an audience issue. 8% of men approximately, many fewer women. It's about 1 in 200 women. But a largish percentage of men suffer from color blindness. So we want to make sure that our audience can distinguish between the colors in our plot so that we're getting our point across. So there's a practical reason there too. Why don't we go ahead and get started? And the first thing we're going to do, actually, I have some of this already set up in some of the Quarto documents set up already, because there's a lot of pre-work in this module. But what we're going to do here to start off with is we are first of all going to run this first code chunk in order to get all of our packages loaded. And these are all packages that we've talked about before. And then we're going to reproduce a plot that we made in the last lesson. And this plot here pertains to the 3 waves of democratization that Samuel Huntington hypothesized. And remember, I said in the last lesson that this plot had an issue, which is that the default colors that it gives, the first 3 default colors in the ggplot output for this line chart, are blue, red, and green. And the most common form of color blindness is red-green color blindness. People with that form of color blindness won't be able to distinguish between this red line and this green line. Okay, so how can we see that? So one way we can do that is we can use a package called the colorblindness package. There are a number of these kinds of packages that are available. We're going to focus on this one for this lesson. But let's go ahead and insert a code chunk here. And we're going to call this code chunk CVD. And what we do first is just load the colorblindness package, and then very simply we take this function from the colorblindness package, cvdPlot, okay, which stands for color vision deficiency. So cvdPlot, and we put the name of our chart. So we've saved our chart as an object up here, demwaves chart, and then we put the name of that object in the parentheses here. There we go. And then we can run that. Okay, and what this gives us, what this cvdPlot function gives us, is a plot with a series of plots that show us what the visualization looks like to someone with normal vision versus someone with different types of color blindness. And as you can see, it's a little scrunched up here. But if we click on this show a new window icon here, okay, and then we stretch this out, and then just let it go, and there we go. So here we have the plot with normal vision. Here we have the plot with deuteranopia. Here we have a plot with protanopia. Deuteranopia and protanopia are different types of color blindness, and I believe the figure in the parentheses here represents the percentage of the population that suffers from this type of color blindness. So both of these are forms of red-green color blindness, and we can see that someone with this form of color blindness couldn't distinguish between the red and the green lines. We also have a plot here that shows us what it looks like to someone with monochrome vision. In other words, a person who only sees in black and white. This is a very rare form of color blindness, but we can use this to kind of plan for our worst case scenario, right? Someone who can't see color at all. All right. Along with this, another thing I want to show you is that if you want to render this, it's going to show up scrunched like this unless you change the default parameters or change the parameters away from the default parameters for the size of the figure. And the way that we do that is with a couple of code chunk options here. So if you go fig width, right, it comes up right away, so you actually don't have to type the whole thing out. It'll autocomplete. So put fig width at about 12 and fig height at about 7, I would say. And then if you render that, it won't change anything. Or if you run the code chunk, it won't change anything. But if you render it, it'll look good in the rendered document. I'll show you that in a second. Okay, looks like that worked. Let me go ahead and drag that over here. Scroll down here, and there you go. So that's what it looks like in the rendered document. But you only get that if you adjust these parameters for the figure width and figure height in the code chunk. Okay, so now we have an idea of how to diagnose the problem. We know how to tell when our plots are not accessible to people with color blindness. So the question becomes, how do we deal with that? How do we make our plots more accessible? We're going to talk about a few options here. The first one is just to create our own colorblind friendly color palette. We're going to be drawing on an example here from the R cookbook. I have this linked in the module so you can have access to that. First thing we're going to do for this example is just to download some data. So we're going to download regional data for the most recent available year on female labor force participation from the World Bank. So we're going to call WB data. Okay, this is the code for female labor force participation. For country, we're putting in regions only. And so that'll give us the regional average for the most recent non-empty or non-missing value. Okay. And then we're going to rename some stuff. We're going to select region, the ISO 3C country code, year, and female labor force participation. And then we're going to glimpse those data. So let's go ahead and load that in. There we go. So next, let's go ahead and include an R code chunk. And this we'll call, we can label this cvdPlot. So let me cut and paste the palette here in the interest of time. So these are hex codes for the different colors, and you can see they show up as shaded boxes for us in Quarto. We are using the combine function to group those in a vector, and we're saving that vector as an object cb_palette. So that's going to be our color palette. And then from there, we can go ahead and build a bar chart, okay, which we're going to store in this object flfp_region. We'll have a ggplot call, and we're going to use the data that we just downloaded. For a mapping, we're going to have x equals, and we're going to reorder according to, x is going to be ISO 3C. And we're reordering in terms of female labor force participation rates. And then y is going to be female labor force participation. Fill is going to be region. Okay, we're going to have different colors for each region, which are going to be represented by these colors here. Okay. Then we want our geom to be column. And then we're going to change the scale of the y-axis. And we're going to use labels equals scales. And here we're calling the scales package. And we're going to use label percent so that female labor force participation rates show up as percentages. Okay, and we're going to use scale equals 1, and let me just show you why we're going to do that. So if we look at these data, we see that they're already exactly as we want them. All we want to do is add a percentage sign after the number and round them. So I would say normally, but oftentimes when we have a figure that's in percentage terms or we want to convert into percentage terms, it's going to be on a scale of 0 to 1, and it's going to be a decimal. So instead of 58, we would have 0.58, instead of 51, 0.51. Okay, and the default for this function, for this scales function, is to assume that you want to multiply every number by 100. So if you leave this in its default, then it's going to turn 58 into 5800, for example. We don't want that, so we're specifying scale equals 1. And you can, I'm not going to mess around with it now, but you can play with it, and that's essentially what you'll find. But that's why we're doing that. And now we'll go ahead and add some labels. Okay, so let's go ahead and run that and see what it looks like right now. Oh, and it didn't like something. It looks like I misspelled continuous here. Let's go ahead and run that again. And that worked, but we need to type out the object here so we get the output. Okay, and that is what the plot looks like with the default color scheme. So let's go ahead now and we will add our custom color scheme, and the way we'll do that is by adding scale, fill, manual, and then for values we just specify our palette up here, cv_palette. And there we go. That's what it looks like with our colorblind friendly palette. And we can go ahead now and just run that through our cvdPlot function. So in order to do this, we need to store the whole thing into an object. So we'll just overwrite our previous object with this. All right, and then we can do our cvdPlot. And see what that looks like. Okay, and let's go ahead and open that up. Okay, and that's not bad. So a person with deuteranopia would have a difficult time distinguishing between pink and green, for example, but there's still enough shading here that you can distinguish between the two columns pretty much. A similar story here with a protanopia, but it does become a little more difficult to distinguish between the different shades of the pink. Looks a little more like a purplish shade, which looks closer to these, so that the distinctions there aren't quite as vivid. And then for a monochrome viewer, you can make some of the distinctions but obviously it's much more challenging. Okay, so another option for making your plots accessible is to use packages with colorblind friendly color mappings. And I'm going to introduce two of those to you. One's called Viridis, the other is called ColorBrewer. They're both used in essentially the same way. These are technically packages, their own packages, but if you're using ggplot, these color mappings are included, so you don't have to load the packages. You can just use them. So I'm going to try to tackle both of these at the same time, kind of. I'm going to create two code chunks here. And we can just call this one viridis. And we can call this one ColorBrewer. Okay, and I'll give you an example of each very quickly. But all you have to do to get this one to work is to take your plot object and then add. You could add it to the end of your plot code, like up here, or you could add it to, save it in an object and then just add the color mapping. So remember earlier we did scale, fill, manual. Here we're going to do scale, fill, viridis, and we're going to use D, discrete, because we have discrete categories that we want to shade, regions in this case. Okay, so we'll go ahead and run that. Okay, and then we can also take that and run it through our cvdPlot function. Okay, let's do that. Okay, and let's go ahead and expand it. Okay, and we can see what that looks like. So this is, even better, I think, than our homemade colorblind friendly color scheme, right? You can pretty much, if you're somebody with red-green color blindness, you can pretty much distinguish between these shades and colors as well as you can with the original. All right, so this is very effective. And notice here we can see the shades of black and white. Like if for a monochrome viewer, this would it would be pretty easy to distinguish between these different shades of black and white, although the background sort of interferes with that, so we might want to choose a different theme. We'll talk about how to do that in the next lesson, or maybe it's the lesson after that, but later in this module. Okay, so we can do the same thing now here with ColorBrewer. So I don't know why I named that Viridis. I meant to call it ColorBrewer. And let's see, from here we can do essentially the same thing, FLFP region, plus this time we're going to say scale, fill, brewer, and then we have to choose a palette. And the one I'm going to choose here is yellow, green, YLGN. Didn't like that. Missing the equal sign here. Okay, and then that's what that looks like. So these are all different shades of green. So we won't have the contrasting red and green there, but let's go ahead and we can pipe that into let's do it this way. We'll do it more quickly here. And then we can pipe that into cvdPlot. See what that looks like. Go ahead and expand that. Okay, and that's not too bad. Pretty easy to distinguish the various shades there. They don't look green exactly, but they are all, because it's all the same color, and different shades of green, um, they are more easily distinguishable to a person with red-green color blindness. Um, Monochrome is, again, always a challenge. Not bad. If we had a different background here, just as with viridis, it might look a little bit better. Oh, last thing I want to note here is, like, how do you know which ColorBrewer scheme to use? There is a palette selector tool that I kind of want to show you here. So this is at colorbrewer2.org, colorbrewer2.org. And here you can select these on these different palettes and see what they would look like on a map, but you know, it's a similar sort of deal with respect to with respect to other types of visualizations. And you can select here on colorblind-safe to only pick color schemes, either multi-hue or single hue. We were using this yellow-green one here, or maybe this one, yellow-green. But you could choose, you can basically filter out the ones that are colorblind-safe. Okay, so the last thing I want to show you guys is how to do color scaling for scatter plots and line charts. And I have some elaborate examples that I made up for the module, but because this video is already running long, I'm going to cut and paste the code here rather than typing it all out and just explain it to you. So first, we're downloading data for the scatter plot. We're downloading female labor force participation and GDP per capita. And here we're calling the WB data function from the WB stats package. And we're selecting the most recent non-missing value for those indicators. And then this is the only part of the code that's a little tricky, is we're doing a left join with region names, because for our country level data in the World Bank, we don't have region names attached to that data when we download it from WB Stats. Okay, so a trick to getting that is to use the country code package, which we discussed in a previous module. And there's a function there, WB underscore countries, which is a list of country names. And so what we're selecting from that data frame in the ISO code package, or sorry, in the country code package, is the ISO 3C code and the region. Okay, so that's this select verb here. And then we're wrapping that in a left join, and we're doing that because we want to join those regions to the World Bank data that we just downloaded. Okay, so we're piping that into this. Okay. All right. So let's just run that and see what those data look like. So here we have the two different country codes. We have country name, date, GDP per capita, female labor force participation, and regions. Okay. And then what we have here is a basic scatter plot like we've done before. We're calling ggplot. We have GDP per capita on the x-axis, female labor force participation on the y-axis. We're coloring our points for the scatter plot by region. We're adding a trend line, which is a low S curve. We are stretching our x-axis on a log scale, and we are making the label a dollar scale using the scales package. We are transforming the y-axis so that it's in percentage terms. So we have a percent sign. Again, using scale equals 1 like the last time we did that. And then we have our labels. Okay, so let's go ahead and run that and see what our scatter plot looks like. And let's put the object name in there. And there we go. We have a warning there. There we go. That looks good. And here we can see we have sort of like a U-shaped relationship between these two variables at low levels of GDP per capita. In poorer countries, we have high levels of female labor force participation, and in wealthy countries, we have high levels of female labor force participation. And in middle-income countries, there's lower levels. And that there are reasons for that we're not going to get into, but it basically has to do with the fact that in an agrarian economy like in sub-Saharan Africa, women are working in the fields and agriculture, and in Western countries, we have more women are more liberated and more educated and are entering the workforce on different terms. So that's an interesting pattern that we see there. But the reason that I want to show this to you actually is to show you how to do a different color scheme. And so we'll go ahead and apply a viridis color scheme here. The only difference, and this is really a long wind-up for this punchline, but basically, or whatever the right metaphor is, but basically the only difference here is that instead of scale fill, we're going to have scale color viridis D. Okay. And then the other thing I can show you here is that we can choose a different color scheme than the default viridis color scheme. We can choose something. There's a whole list of them. If you go to the viridis website that's linked in the module, you'll see one called magma, one called plasma, cvdis is another one, and we can go ahead and just see what that looks like. Okay, and that's what the plasma option looks like, and like I said, you can change that to magma or something else. All right, and last point here is same thing with respect to line charts. I'll just go ahead and quickly explain the data here. So this is basically time series data for regions from 1990 to 2022. We're downloading female labor force participation data again, but these are time series data for our 7 regions. Okay, and we're going to build a line chart with that. So x-axis is year, y-axis is female labor force participation, color is region, geom line, scale y continuous with percent label, and then our plot labels. X-axis, title, caption, etc. Okay, so here we can do FLFP line plus scale again, color, and we'll do brewer this time, and we'll choose the palette YLORRD, yellow, orange, and red, okay, which is a colorblind-safe palette. Didn't like that. What did I do? Oh, I spelled palette wrong. And that's what that looks like. All right. Personally, I'm not a huge fan of this particular color scheme, but I just wanted to show you how you change the color scaling for a line chart using scale color brewer or viridis as opposed to a scale fill. Okay. So that's it for this lesson. One thing I neglected to do is to actually put in text. I'm always telling you guys to put text in to describe what you're doing. So I'm going to go back and do that now, and then when I play this back for you, it'll be in double time, so you don't have to sit through all of it. But here we go. Okay, and that's it, and we're done, and let's go ahead and render, save the document and render the document, and have one last look at it. There we go. There it is. There is the fruit of all of our labor. Okay, so that's it for this lesson. In the next lesson, we're going to be looking at how to add a theme to your plot.